Hello, so in this video I'm going to go through part D of question 1 on the 2012 math paper. So in this question they've given us this diagram. So this is a square with its vertices at 0, 0, 1, 0, 0, 1 and 1, 1, and the line y is equal to x plus c. And they've called this the area of this shaded region AC, and they want to know which of these graphs is the graph of AC as C varies. Okay, so as we vary C, we're just going to be moving this line along the square. And so if we think about what's the area, how the area increases when we do that. So when C is at -1, then the area is just going to be 0 because we're only touching that point of the square. But say I had C being here, then what I am adding, and if I moved it a little bit along, then the area that I'm adding on is just this little sliver here. But say I had my line up here and I moved it a little bit further along, then the area I'm adding on is everything in here, and we can see that that's much bigger. So as we move C from -1 to 0, which is when it will go through the diagonal of the square, we can see that the rate of increase of the area is going to be increasing. But then when I move past 0, then when I add the area on, it's going to be decreasing again. So here it's only this little area. So we have that the rate of the increase of AC is going to be increasing up to C is equal to 0, then it's going to be decreasing again. So we're looking for a graph of the gradient that's increasing up to 0 and then decreasing, and to me that looks like A. Now we can also do this more rigorously. So if you look at this triangle for C between -1 and 0, then the area is just going to be, AC is just going to be a triangle, the area of a triangle. So we can write down a formula for AC. So we can see that this point here is just going to be minus C, right? Because here is C, which is negative. So we know that this length, the base of this triangle, is going to have length 1 minus C, so that's just going to be 1 plus C. And because the gradient of this line is just 1, we know that this height is going to be 1 plus C too. So we can see that because the area of a triangle is just a half times its base times its height, then AC is just going to be, the area of this triangle is a half times 1 plus C times 1 plus C, which is the same as for C between -1 and 0. And so we can see that in this range, then AC behaves a bit like an x squared graph. And we can see the coefficient of the c squared term is going to be positive. So we see that in this range for C between -1 and 0, AC is going to have a shape like this. So this would be when C is -1 AC will be 0 when C is -1, and it'll be like an x squared shape. And you can indeed see that the only one for which that works for C between -1 and 0 is A.